So thank you everybody for being here today. Thanks for the organizer for putting up such a interesting developers conference. And as was introduced by the chairman, so yeah, we're from the ROS Industrial Consortia. I'm from Fraunhofer IPA. We're managing the ROS Industrial Consortium Europe. My colleague here, Shaun Edwards from Southwest Research Institute, is here on behalf of the ROS Industrial Consortium Americas. So we'll give you an overview of what the two consortia do, and actually of the wider ROS Industrial Consortium project, which is much more than the consortia itself. So I'll give you an overview of what is it like from an ecosystem business, if you want, perspective. And the second part of the talk, Shaun will give you a more technical insight. So we've seen incredibly good things here at ROSCon, and it's progressing very fast. But still, the focus might be service and research robotics, though it's moving fast into products, as we know. But actually, we might want to connect to the internet for the videos. If you can find a cable for them. Yep. So why then ROS Industrial? So you can really use this stuff to push industrial robotics from what we could summarize as pre-programmed motions, which most industrial robots would do today, to something using perception in the loop, dynamically generated trajectories, plus all the very nice tools that are around allowing debugging, visualization, simulation, the hardware independence that ROS can buy you. Those are really of great value to industrial users. But after the why, so then how do we do that? So now it's 3 years, roughly, since the project started, from the intuition of Shaun, so from the intuition of a research engineer who actually did an internship at Willow in 2011, and then came up with the idea of starting a proper project. We decided to back it with a consortia, which now grew over 30 members. So in terms of timeline, as I told you, the whole idea was incepted in 2011, and actually the first public appearance was at early 2012 at the Robotics Industry Forum, where Shaun first publicly spoke about it and received some initial feedback. It was encouraging in this direction. So fast forward 1 year, and actually in March 2013, actually the ROS Industrial Consortium Americas launches. I hear also on behalf of Paul Vass, the manager of Industrial Consortium North America, and they were pretty successful in launching it and growing it over the years. So now the project, which, as I said, it's more than the two consortia backing it, so it's an open source effort. It has a community. Actually, this afternoon we will have, during the Birds of a Feather session, the 5th ROS Industrial Community meeting. So, but now the project is backed by a consortium, soon to be followed by the European one, which provides financial and managerial support. So one of the first instruments that the consortium came up with is the so-called focus technical projects. So the spirit of the ROS community is very successful into having this grassroots movement, if you wish, come up with interesting community-driven bottom-up approach. So a lot of people, federated approach, coming up with very interesting software projects, but sometimes it's at odds with what the industrial world is used to, which is more like a contracted world thing. Like I know I need something, and maybe it's just me needing it, so I will contract it to somebody, and you do the thing, and that's it. So they are at odds sometimes. So you want to blend those two things, and those are some of the examples of the first FTPs. Oh, sorry about that. The real goal behind them is to reduce what we call unnecessary parallel work. So if you have just some infrastructure costs that you need to bear, which are not actually, this infrastructure is not actually linked to your core intellectual property, well, you might just want to share the costs, teaming up with other institutions. So in the meanwhile, since actually during the internship of Shaun, also some colleagues of mine from Fraunhofer IPA were at Willow at the same time, and they kept in touch. So there were some initial exploratory events in Europe to assess whether something similar would have been successful. Actually, I was myself an attendee of the first ROS Industrial Conference in 2012. At the time, I was working at a system integrator and AGV manufacturer, so I saw the potential for it, actually coming from industry. And also the success of that event made it such that the decision was to move forward, so that 1 year after, a bit over 1 year after the ROS Industrial Consortium North America was launched, In June 2014, this gentleman came up with the ROS Industrial Consortium Europe, which, again, managed by Fraunhofer IPA, and with Technical University of Delft as a scientific advisor. So one of the other missions of the consortia is actually to spread the word. As I said, industry has quite some benefit to reap from ROS, but they are used to a completely different set of technical tools, and they have a lot of technical staff which is trained with, to use completely different technologies. So training is quite valuable to them. So we hold training sessions regularly, both at Zurich in Texas and at IPA in Germany. Then there are other outreach events at which we speak in industry venues and business venues about the benefits of such an endeavor. And actually, I can tell that even though my tenure at IPA is relatively short, but I'm seeing good progress on it. So I think people out there are realizing that at least they cannot ignore us, and actually they might just benefit from it. So it's gone a long way since what I heard from industry representative in 2012. So another very encouraging thing is that we start seeing ROS in industrial products and settings. So a couple of very interesting examples, since now we're talking factory floor and very traditional settings. So metal welding, big robots moving metal parts. So this is an example of a motion controller made by an Italian company with this Italian system integrator, which actually ported their CROS library. It's an NCC single-threaded library implementing some of the features of ROS, a subset of the features. And yeah, it's open source, as you see. It has been contributed earlier this year. And yeah, they use it in a real product, this motion controller, but it's also used, very interestingly, as the middleware to glue different modules of a leather processing plant for a big company which has plants all over the world. The first prototype was in Italy. And other interesting examples are ROS on AGVs, starting from the beginning of this year, operating at a major car manufacturing plant in Germany by a German manufacturer of IGV with the help of Fraunhofer IPA for the integration of navigation and other advanced features using ROS. And again, what I heard in 2012 at the first kickoff meeting, actually at the first exploratory meeting, because the kickoff would have been 1 year later, was, this thing cannot work, it's open source, and the licensing isn't clear, but actually we have it running in one of the countries with probably the strictest safety regulations around, so it can be made to work. And now the examples for intermodalics for depalletizing, the nice products coming out of Magazzino, and many more, Fetch, Baxter, so it's coming there, so both factory floor and products. As I said, it's not just about the two consortia. I have a lively community, and again, I encourage you to join us during the Birds of a Feather session this afternoon, room 121, West Wing, for our 5th community meeting. These are some of the examples of the topics. Something could be a bit boring, like towards a single universal robot driver, or, oh, what are the KUKA, EVA drivers around, but that's necessary. That's necessary. Those are the topics that we want to sink in to move forward with the project. So now we get to present day. So what's cooking right now? So we have a few proposals for FTPs and candidate topics which are maturing into FTP proposals. So this is launching right now, and you can find it already. So you go to rosindustrial.org, you find a template for the FTP. It's an umbrella project called CAD to ROS Workbench. So it's split, as often happens with our FTPs, in few milestones. But the news is that we're trying a hybrid approach this time. So we have one of our members who committed to fund the first milestone, but then the thing is, through crowdfunding, we can liberate the source, which could normally be kept closed for 2 years if we get to a threshold. And you get the binary if you commit the crowdfunding money. So it will be interesting to see if this hybrid approach works, because as you know, we have to balance between the two approaches. As I said before, the bottom-up community-driven and the contracted work guys who typically would like to keep what they pay for. So this could be a nice middle ground. And then other two topics that are brewing here in Europe is bringing this NCC library on PLCs. We already started working on it, collaboration with a major PLC manufacturer here in Europe. And again, having one foot in industry and one foot in this kind of communities, it's interesting to hear their comments. They're like, oh, we heard about this ROS 2.0, but why are they going with DDS? So don't you know that Industrie 4.0, so this Industry 4.0 initiative here in Germany, but pretty big in Europe overall. So it uses OPC UA as a communication standard. So we're looking into having a pilot project, like coming with a prototype of ROS 2.0 with OPC UA. There's a draft for a white paper online, which mimics the ROS with DDS paper about assessing whether OPC UA could be doable as a middleware. So, as I said, we grew over 30 members, and I'm also very happy about the feedback that I had during those 2 days. And yeah, we want to thank our members for their continuous support, and we look forward to an even more extended family. So thank you for your attention, and I will now pass the mic to my colleague Shaun Edwards.
So I'm going to focus on the technical aspects of the ROS Industrial project. And Mirko did a really great job of laying out sort of the ecosystem or the business part of ROS Industrial, which I think is equally as important as the technical side. But you know, I think everybody in this room is very interested in technical details. So, whoop. There we go. All right. It does not seem to like this, but we'll move forward. So in the very beginning, this was 4 years ago, we were at Willow Garage. Both Willow Garage, Yaskawa, and Southwest Research came together, and you can try if you want. They came together and they basically said, hey, we'd like to take ROS, which was limited to service robotics and, you know, and research institutions, and deploy it on an industrial system. See if that was even possible. You know, from a technical perspective, we can see how it all could be done, and we understood that, you know, because ROS was developed to be robot agnostic, that should be possible. But nobody really believed it, and certainly not in industry. When it comes to industrial robots, they're very proud of the software and the capabilities that they have. They were impressed by what they saw at Willow Garage, but they didn't make the connection that they could leverage that work. So the most impressive thing that Willow Garage was doing at that time was the PR2 kind of pick and place application. I still think it's impressive today to see. And it basically integrated 3D perception for identifying objects, and then the kind of intelligent path planning like you saw in Move It for grasping objects off a table and putting them somewhere. And so this is a really advanced capability. In industry, you couldn't actually buy this capability. And if you had to develop it yourself, it was going to be very cost intensive. So what you're seeing here is the PR2 performing the pick and place. This is a video I'm sure a lot of us are very familiar with, but it's still very impressive in its own right. And then what you see is the same software running on industrial hardware. And so this is a Motoman manipulator. They were one of our partners in this effort. And this alone really sold industry on, hey, ROS is something to pay attention to because look what it can do. There's some fun Move It path planning there too. At that time it was ARM navigation, so I can't really blame Move It. So what this really did is demonstrate software portability, and it got industry to buy in, right? There we go. All right, so after we got industry to buy in, we started this idea of developing these consortia. So we spent the next part of a year trying to get that consortia in place. And we went out to industry and we said, hey, look at ROS Industrial, we got one video. Is it awesome? And they said, yeah, it's awesome, but I don't like that robot. You know, I like my robot. My favorite robot is yellow or orange. It's the way it is. So we spent that time, in addition to like going out and talking to a bunch of companies and trying to get their buy-in, we spend a lot of time developing support, drivers for other industrial platforms. And we see this as a core reason for ROS Industrial. A lot of these robots are very expensive. Not a lot of universities and certainly not a lot of developers have access to them. We're lucky in that we got access to a lot of these platforms in our labs, so we would provide driver support, the connections between these industrial platforms of any color and ROS, right? And we would do it in a way that you could use any one, right? There would be no vendor lock-in. That's a core tenet of ROS. So we did ABB, Adept, FANUC, Motoman, and Universal early on. And I have to say I'm really thankful to Southwest Research, TU Delft, and Fraunhofer IPA for continuing to maintain these drivers. It's been like 3 years now, but things need constant maintenance. In the future, we do expect other companies like KUKA, Epson, Stably to come in, and Ragnar, which is a new robot by Blue Workforce, is one we're working on actively right now. But at this point, we're kind of expecting vendors to come to us because you guys are doing great things, and you go to companies and you say, hey, do I have ROS support for my robot? And if they don't, you say, okay, I'm not going to buy it. I'm going to buy some other robot. That's driving their behavior, and I really appreciate it. I will say that as soon as we had one arm working with ROS, there was a lot of interest in getting two arms working with ROS. And that effort was actually spearheaded by Fraunhofer IPA and Motoman. And again, it's not a huge technical leap to go from one arm to two arms, but there was some driver development that had to be done, and there was, what I will say is that ROS has really good support, relatively speaking. I mean, it's not great, but good support for kind of dual arm motion planning, task planning, those kinds of things. A lot of that enabled by MoveIt, so we're very happy for that. But it really does compete with industry. Industry is excited about two-arm robots because they look like people, but the tools just really aren't there yet. And with tools like MoveIt, we can really bring it to the next level. The idea behind two-arm robots are drop-in replacements for people. That means we need intelligent software, as intelligent as people, for simple tasks, and that's what ROS enables. All right, so zoom out a little bit. In late 2014, we started working on our calibration toolbox. And, Dave brought this up in his talk, but in industrial applications, we have to calibrate all the time. And it's a very painful process. You have to calibrate your robot relative to your camera, relative to your conveyor system. It's very time-consuming. It's not always very accurate. But we felt there needed to be more support within ROS, and hopefully come away with better calibrations than you can with commercial software. This effort was funded by Southwest Research and NIST, and we really wanted to address three core problems. Robot-to-camera calibration, where the camera is fixed, so the camera's looking back at the robot. Robot-to-camera, where the camera is actually arm-mounted, so it's moving on the end of your end effector. And then camera-to-camera, or many-camera to many other cameras. So these were our three kind of cases we wanted to address. And we did that developing a very general framework for calibration. So we have our eyes on future applications. The core of that toolbox is a nonlinear optimization library from Google called Series. And the great thing about Series is it allows you to develop a calibration toolbox that is very general purpose. Although maybe not so easy to use because it's so general purpose. So we developed that, and it's been very successful. I did say it wasn't necessarily easy to use, even for myself. So when I have to calibrate a robot to a camera, I walk down the hall to Dr. Chris Lewis, who wrote the calibration toolbox, and I say, give me the config file to calibrate this system. It's very convenient that I get to do that. Not everybody here can have that ability. So, in the future, what we're going to develop over the next few months are templates for these common use cases. And that should make this very powerful library very easy to use for these typical use cases. The other improvements we'll make is streamlining intrinsic and extrinsic camera calibration. So currently you have to intrinsically calibrate all of your cameras and then do the extrinsic calibration, which includes robot to a camera, camera to camera, those kinds of things. We'd like to streamline that so that it happens much quicker and maybe happens all at the same time. I'm going to skip that video for time. So after we developed a calibration toolbox, we set our sights on path planning. And Dave kind of hinted at some of this path planning. And I'm going to give a later talk on Descartes, the library that we implemented for one of the libraries that we implemented for path planning. So here I'll just give you a little bit of the overview of what we decided to tackle related to path planning. So in an industrial application, the requirements are a little bit more rigorous. If for no other reason, then it's kind of a perception issue. So if I told somebody in a factory, hey, when my robot does the same motion, right, going from point A to a similar point, it might choose a different way to get there. Nobody's really comfortable with that on the factory floor. It has to be very predictable motion. So it has to be repeatable. If I give it the same start and end goal, I should get a very similar answer. It also has to be scalable. MoveIt at this point is really developed for solving some pretty complex problems. But at the same time, it gives some pretty complex answers when a simple answer, such as just joint interpolated motion, might have worked just fine. So we needed to create path planners that solved easy problems very quickly, but also could scale to the complexity of problems that MoveIt's better suited for. And all this kind of leads to what we call common sense path plans. So when the robot moves, even if it's completely autonomous and it's making these decisions itself, it has to appear like a person programmed it. So little bit different. So out of this came two path planners. The Descartes path planner for semi-constrained Cartesian paths, and then the STOMP path planner. And here's a video of the STOMP path planner. We're actually comparing it to the MoveIt path planners. So it's a very simple application. We have a robot that's rail mounted, and we put an obstacle in its way, and we said go from one side of it to the other. And with MoveIt, because it's kind of a random search, and it needs to be, believe me, it needs to be in order to be computationally efficient and solve these problems quickly, you sometimes get very odd answers. So you can imagine a pure search base, which would give you maybe a more realistic answer, but it's not computationally efficient in these kinds of spaces. So STOMP is kind of the middle ground, where it basically tries to find a shortest distance between 2 points and then adjusts for obstacles. You can also see that it doesn't get really close to obstacles, kind of like the MoveIt OMPL path planners. And this is work that we've done recently, and it's migrating into MoveIt as we speak. And I'm going to skip the Descartes video because I'm going to show that to you guys later. So just recently, this year, so 2015, we started focusing on mobile manipulation. This is a very, very interesting area in the industrial space. A lot of robot vendors want to put their robots on mobile platforms. A lot of mobile platform developers want to put robots, manipulators. The problem is there's no integration software. You get two separate software stacks, and they may not even talk to each other, but they certainly don't allow you to easily integrate mobile motion and then manipulator motion. But within ROS, we know this is pretty trivial, right? The PR2 was a mobile manipulator. So all that was already built in. So what we decided to do is, based on some client needs in order fulfillment, we would create a standard platform from which we could do development, and we would then open source that software and tell everybody, hey, here's how we built it. We took a mobile base with Mecanum wheels. We put a Motoman MH5 robot on the end of it, and integrated laser sensors from SICK, and put all that together, and we put a package out there that just works. We also got simulation for this particular setup as well, so you don't even need the hardware to get started. And if anybody has tried to set up the navigation package, sometimes that can be very difficult. Well, here's a very good example with our Euler platform of how to do navigation. And by the way, the reason we were successful at this is because when we knew we needed a navigation solution, we went right to the maintainers of the navigation stack and said, we're going to pay you to help us develop the navigation stack for Euler. David Liu actually is the one who did that. And I think leveraging the community that way, and even paying the community, is a really good thing, and I'd like to see more of it. I'd like us to do more, and I'd like to see other people do more. So another thing we've heard recently is I/O network support. So in the industrial space, there's a lot of effort over decades that's been put into putting a device on a network and talking to it. It's really the Internet of Things, and we were doing it like 20 years ago. But now it's really exciting, Internet of Things, but there's a practical need for it too. In factories, we still have these network systems. They're older protocols, they're industrial protocols, but we need hooks for ROS in order to use those. So the first one that we did, Fraunhofer IPA actually implemented, was ROS support for CAN-open devices. So CAN-open is a standard industrial protocol. We provide direct hooks into CAN-open. The use cases that we've done to date have been motion control related, so that's where the best support is. But CAN-open is an industry standard, so theoretically other sensors or other actuators that are CAN-open or can speak CAN-open would easily be supported. If you have examples and it doesn't quite work, let us know, because we want to know about those things. But the guys at IPA are working very hard to make that a world-class package. And then recently over the summer, through a Google Summer of Code supported effort, we had a student develop a ROS Profinet interface. For those of you that aren't aware, Siemens has developed the Profinet protocol, which is an Ethernet-based protocol for industrial I/O networks. I think it's the largest one, or Profibus and Profinet together are the largest kind of I/O networks. So ROS support for that means access to anything that speaks Profinet, everything from drives to sensors to robots. So those are important connections that we've made. So now we're going to look into the future just a little bit. I talked about all these technologies that we've developed, which are calibration and intelligent path planning, robot drivers. All these technologies were going somewhere. By themselves, they solved an individual need, but we had this vision, and this vision is really scan and plan. It's this idea that a robot should be able to look at its surroundings and then identify objects of interest and perform some operation on them. And this is a very industrial application, I'll hand you that. But you know, the idea is, if I want to paint an object in front of me, I just look at it, I have intelligent software that understands how to paint, and then I have intelligent path planners that understand how to make the robot actually do that task. So this video, there's going to be a talking guy up there, but obviously you won't hear the sound. But I'll give you a little background. So this is a ROS Industrial focused technical project that Mirko had talked about. It was funded by the Boeing company and Caterpillar, and they have a need essentially to blend. They call it blending, but it's really mechanical or grinding application. So when parts come out of a CNC, they need to be smoothed out. And this process is a very manual process, believe it or not. Teams of people actually grind out tool marks on CNC parts. But our idea was, let's take the 3D perception and the intelligent path planning, all enabled by ROS, and let's integrate that into a very intelligent robot work cell that does robotic blending. So the first thing we do is take the scan. We then identify potential surfaces. There's some user interaction here, so the user actually points out, okay, these are the surfaces you really want to hit. We then simulate that motion for the user so that the user can say, okay, that's what I want the robot to do. In this case, there's two operations actually, a blending operation and then a inspection operation where we take a high resolution 2D scanner and make sure that our grinding job meets the quality spec. That kind of in-process quality inspection is very important for manufacturers. And then you can see actually executing this on real hardware. So I'm going to let it go through this quick blending process, and then you'll see the arm actually come up, flip around, and expose the sensor side, so the laser scanner, and then come down and perform automated inspection. So this is a very flexible solution. You can put almost any part in front of it, and it can figure out how to do it. And we see this expanding beyond blending applications to painting, deburring, welding. These are all very important industrial processes. So with that, I'll just say that, you know, I hope what you've gotten out of this is that ROS Industrial is really a program focused on solving problems on the factory floor. That's really what we want to do. We're very open to what you guys, to involvement from you guys. We want to invite people to join us, and Mirko does a great job of doing that. I will also say that the technology we've developed is kind of specific to industrial applications. You know, we push it all back into ROS as much as we can, but we don't feel, and we didn't feel 3 or 4 years ago, that this technology would be developed by the community. Hence the need for ROS Industrial. And I would say that, you know, if you're not interested in industrial applications, the takeaway from this talk for you would then be, well, what am I interested in? Can I organize a group specifically focused on doing technology development and outreach to people who are interested? Because I can tell you that the message has to be targeted to the group of people you're talking to. So a good example is we have a lot of people doing work on autonomous vehicles, but we don't have any cooperation. And at that, because of that lack of cooperation, you know, there's an opportunity there for somebody to step up and say, okay, we're going to create that ecosystem. And again, develop technologies that are specific for autonomous vehicles.
How do you think ROS Industrial might do or is doing or has considered things related to 3C manufacturing? They require high accuracy, very low tolerance error, very small parts. Do you have any experience with that?
I don't have a lot of experience with that. You know, a lot of the 3D sensors that we're dealing with these days, like so the ASIS, aren't that accurate. There are more industrial sensors that are. They tend to be very slow in image acquisition, and that hurts things like throughput. But you know, I'm happy to follow up with you because I'd be interested to understand the use case a little bit more. And you know, from a software perspective, we can do anything, right? But you know, I think there's probably more to it than I understand at this point.
What's your level of involvement with trade schools and technical schools where the people who are going to be programming these in a couple of years are currently learning? Are you trying to do trainings there, or?
Well, we do host students for internships at Fraunhofer IPA, not just from years to Stuttgart, from there primarily, but from well, around Germany and around Europe as well, actually. Some of our colleagues, some of our foreign colleagues actually came there as Erasmus students, interns, and then stayed and then spread the word back there. So we do actually are pretty active in that scene, and actually we are invited to higher education forums in which they discuss, okay, so what are the topics that you're dealing with now? So yep, there's a strong connection to that.